Okie dokie. So here we are, week 23, part 1, and we are talking about radian measure, which we already know. It's related to degrees, and it's how we measure angles. And then these other aspects of a circle, which you probably remember from geometry, arcs and sectors, and how that relates to radian measure. So our favorite example, pizza, yum, we will bring that into play. So here we have our circle. Let's zoom in. So you remember unit circle, we would split it up like this. We talk about this location being our starting point, okay? It's called standard position. And when we measure angles, the angles go in this direction, so we rotate counterclockwise. So something like this, that would be about 60 degrees, and so on. So when we talk about pi, this is useful in talking about radian measure. So we talk about this angle being 180 degrees and being equal to pi radians. So let's review briefly the definition of what radian measure is. So if we have some angle, we can relate that to a piece of pizza. Okay, and so let's see. Hey, this is cool. Alright, so there's our piece of pizza. And when we talk about the arc, we're talking about the length of the crust. And when we talk about the radius, we're obviously talking about the radius. So radian measure is a measure of the angle, okay, so how wide this piece of pizza is. And we can define it as the length of this, the crust, divided by this length, the radius. So, let's see, pizza, get out of there. So when we talk about radian measure, we can say that the angle measured in radians is equal to the length of the arc divided by the radius. So what on earth am I talking about? If we zoom in and choose a different color, we can highlight our crust. And so that is the arc, which we're using the variable s. Don't ask, I didn't make it up. And we have the radius. Okay, and here's our angle. So radians don't have any units, whereas degrees, we talk about them in terms of degrees. It's actually a ratio of a distance to a distance. So that's a review of the definition of radian measure. And, well, I'll just throw this in there, because since we're reviewing. So the other thing to consider is that 180 degrees equals pi radians, and we can sometimes just write rad for radians. So yeah, I'll leave it at that. Okay, because we already know. So for radians, we say that, well, this is what we know, sort of by definition, s over r, so arc over radius. And then to find the arc length, if we were to just rearrange this formula and get s all by itself, we would have the arc equals the angle times the radius. And again, this has to be measured in radians. So let's be specific. In radians, if you were to put a number in degrees in there, you would get a very different and wrong answer. And then by sector, we're talking about the area of the pizza. So here's our pizza again. Alright, and let's see. This is, yeah, well, okay, there it is. So when we talk about the sector, we're talking about the area of the piece of pizza. Thanks, pizza. Excuse me. So, sector, we're going to zoom in. This is the area of piece of pizza. And I'm just going to use that as definition because you'll know what it means. And if we were to come up with a formula for that, we could consider that the piece of pizza is some fraction, and I know don't freak out when you hear the word fraction, it's some fraction of the whole. So let's look at this. If I were to give you this example, you'd say, well, no problem, I know that this piece of pizza is 1/4 of the whole, and you probably remember that the area of a circle is pi r squared, and so you could say, well, the area of this piece of pizza is 1/4 of that. So what we do is we say that the piece of pizza is 1/4 because we could take this angle and say it's 1/4 of the 360 degrees or whatever. So the area of a sector we're going to have to multiply by. So this is the entire area, and this is the ratio or the fraction of our angle over all the way around, or 360 degrees. And if we're talking about radians, it would be our measure in radians divided by all the way around, which is 2 pi. So we can say our angle in radians over 2 pi, this is some fraction of the whole, and if we simplify this formula, the pi's cancel, and we end up with this. So area of sector is, and the 2 is in the denominator, so we can write that as 1/2, and we have r squared times theta. So this is the formula that we will be using to find the area of the sector. And let's go through some examples. So, sorry pizza, you're out of here. Example, all right, so you write them here, 1, 2, 3, and 4, and I'm going to sort of turn the page because I needed a little more space. So, is example number 1. You might want to write the question in there so that these are useful to you in the future. Here's our diagram, and the question says, find the length of the arc S in the figure. So again, arc is the pizza crust, and we want to know the length, meaning that distance. So this is kind of cool. We're finding the distance of curved lines now. That's probably new. And we know that the length of the arc is equal to theta times r, where theta is the angle in radians, and then times the radius. So we know the radius, that's 5. And our angle, we cannot put 140 degrees in there. No, because that's in degrees, and it would be a really big number. So we need to figure out how many degrees is 140, how many radians is 140 degrees. So here's 140 degrees, and our conversion factor, we know that pi radians is 180 degrees. And we can just plug that into our calculator. For this unit, last unit we talked about radians in terms of pi because it was these nice equal fractions and you could just sort of divide it up and look at it. This unit, a lot of the time we will actually deal with decimals for radians. So after doing all this, now why do we have, this is not right. This is the angle we're interested in. Look at that. It almost threw me off course. So to figure out how many degrees that is, we're going to subtract and get 220. Shame on you, Torville. So here's our 220 degrees. It's early, that's my excuse. And we multiply, and we're going to end up with this for our number of radians. And so don't freak out when you see radian measure not in terms of pi, okay? Just as a little aside here, 1 radian is about 60 degrees. So when you get this number 3.8, you can think, well, 3.8 times 60 degrees and see if it makes sense. And you're like, oh yeah, that, about 240 or something. 1 radian, approximately 60 degrees. It's actually, to be more specific, something like 57.296 degrees. Okay, so, hey, get out of there. All right, back to the question. So we're looking for the length in red, and so this is the length of the arc. And we know that this is 220 degrees, so we're figuring out how many radians that is. We could label this as 3.8. let's see, I need a smaller, here we go. We could label this as 3.8397 radians. Notice how I'm using a lot of decimal places within the calculation. For our final, we'll round it, but if you're within the calculation, use lots of decimal places. So when we substitute into this equation, we say that the angle in radians, 3.8397, and then times our radius, and that will equal, so when we multiply these, let's see, I got 19.2. So let's take a look. Does this make sense? If this is 5, does that look like it could be 19.2? Totally. So that is the length of our arc, the pizza crust. Here's example number 2. It says find the radius of the circle. So we're looking for a radius. That's a circle. If the arc of length 6 on the circle subtends a central angle of pi over 6 radians. So we've got some words here, subtends and central angle. Start off as we do with our circle, and you're familiar with this. That looks a little better. So this looks like pi over 6. And if you didn't remember, you could just convert and you get 30 degrees. But remember, we could split this into thirds, or the top into sixths, and then we'd have, okay, so that's pi over 6. Oh, great. Whoops. So here's pi over 6. So radius is what we're looking for. We have a circle. The arc is 6, so that distance is 6. So subtends a central angle. Central angle just means the vertex is at the center. This is a central angle. And subtends meaning sweeps out. So sweeps out. You could think about windshield wiper. The windshield wiper starts here and it sweeps your windshield all the way over to here. So this word subtends just means it sweeps out that angle. So we have pi over 6. And what are we looking for? Radius. Okay, so our formula, we know that angle in radians is equal to arc over radius. And if we substitute it in, we would get, we have pi over 6. That's a 6. And a 6 here and an r here. A real common mistake is people would just divide by 6 and call it good. No, our variable's in the denominator, so we're going to cross multiply. So we get r times pi equals 6 times 6. And our radius ends up being 36 over pi. And what do we get? 36 over pi, and it looks like 11.5. So we have an answer. Look at your diagram. Does that make sense? If this is 6, does it make sense that this is about 11.5? Sure. Because a lot of the times people will get answers like 0.2, right? And if this is 6, this is obviously not 0.2. So you can kind of check yourself before you wreck yourself by looking at the diagram and seeing if it makes sense. Okay, the measures of two angles in standard position are given. Determine whether the angles are coterminal. All right, so what on earth does this mean, coterminal? We talked about unit circle, and we would draw an angle, and then this right here I was always calling the terminal point. Whoa. So terminal point. So two angles that are coterminal would be angles that sort of end up in the same spot. So for example, we could have this angle, and we could have this angle, which would be negative, and those two angles would be coterminal. because they end up in the same place. And as far as sine, cosine, and tangent are concerned, these two angles would have the exact same sine, exact same cosine, and exact same tangent. So we got that. Let's see. And to figure these out, you should just draw them. All right, we're pretty familiar with drawing angles and knowing where they are. So here's our unit circle. We're looking at 70 degrees and 430 degrees, and are they coterminal? Do they end up in the same place? So this is about 70 degrees. I might try to zoom in a little more. And then if we're talking about 430 degrees, let's color code. We have 70. Whoops. 70 and 430. So if we're talking about 430, this angle would go 90, 180, 270, 360, and then how much more? So 430 degrees, and if we take away 360, we're left with 70 more degrees. So this is going to go 70 more degrees like that and end up in the same spot. So that was 430, 430 degrees. So we say yes, these are coterminal. They end up in the same spot. And you could check, you could type into your calculator, hey, what's the sine of 70 degrees and what's the sine of 430 degrees? And your calculator will tell you they are the same. Next up, so get out of there, we have negative 30 and 330 degrees. So negative 30, we know we go in the opposite direction. A little slice of pizza right there. So this right here is negative 30 degrees. And for the 330, let's see, we go 90, 180, 270, and 60 more. So that's 330 degrees, and aha, these are coterminal. They won't always be, but for these two examples they were. Yes, coterminal, because they end up in the same spot. Okay, last example. Here we go. So question 4 says the area of a sector, oh good, so now we're finding area of the piece of pizza, of a circle with a central angle of 2 radians. So central angle 2 radians, notice how this is not in terms of pi. 2 radians, remember that 1 radian is approximately 60 degrees, so we're picturing an angle of about, the little squiggle equals is about 120 degrees, is 16 square meters. Find the radius of the circle. So we're going to draw a picture like this. And just to help me visualize, I'm going, all right, about 120 degrees. So something like that. Yum. Nice, big, healthy piece of pizza. And what do we know? We know that the area of a sector of a circle, central angle, 2 radians. So this is 2 radians, about 120 degrees, is 16 square meters. So we know that the area is 16 square meters, and we're looking for the radius. So R equals question mark. Our formula for this, we have that the area of a sector is 1/2 R squared times theta, where the angle theta is in radians, which we know. So our area is 16. Our radius, this is what we're solving for, radius, and then we know that our angle is 2 radians. So times 2. And in solving, looks like the 1/2 and the 2 kind of cancel. And our radius would be 4. So that's it. Thanks for listening.